Okay, on a side note, if we came back here. I didn't even need to go. I didn't even need to multiply that shit out. Fuck you, red pen, you're dead to me. All the way back to the x minus 1 times x minus 1 plus b times x minus 1 plus cx. All the way back there. So rewind. C was 7. And push up at the C in. Only need B. Rather than going through the work of equating the coefficients, I could just pick another value for x. Try picking another value for x. Pick one as simple as possible. We did 0 and 1 already. 2 is not bad. Let's do it 2. If x equals 2, this is -2 times 2 squared plus 7 times 2 plus 2 equals 2 times 2 minus 1 times 2 minus 1 plus b times 2 times 2 minus 1 plus 7 times 2. Yeah, -8 plus 14 plus 2 equals, that's a 1, that's a 1, that's a 2 right there. Plus 2b plus 14. Subtract 2 and the 14. I get -8 equals 2b. Divide by 2 and I get b equals -4. Which might be a little bit easier than multiplying all that shit out and equating coefficients.
I'm hungry.
That is fascinating. You're hungry?
Yeah.
Dog, you're at home. Go grab some food.
No shit.
Oh, I don't have time, man. I have to go ahead with the.
All right, ready to kick it up a notch? So far we've dealt with terms that have ax plus b on bottom. What if I've got like an ax squared plus bx plus c term on bottom? So if you have it where that, and there's no way of reducing, and you can't simplify, that's the important part. And you can't factor. What you do is, instead of just putting a single letter on top, what you do is you put to 1 degree lower on top. So we just write with 1 degree lower on top. So let's give an example. I have 4x squared plus 6x minus 10 all over x plus 3 times x squared plus x plus 2. I'm going to have a denominator with an x plus 3. And I'm going to have a denominator with x squared plus x plus 2. On this one, I will put a, and this one will be bx plus c. Now, a lot of you will probably never need this, but if you need to take Calc 2 for your major, there's a section where knowing how to do this is helpful. You're gonna have to do it then. If you at least get it figured out enough now, when you see it again, when you get to Calc 2, it's probably a year or so away. You'll at least go, that looks familiar. Again, clear fractions. All right, so, well, I know at least one thing that makes it 0. X equals -3 is a bad number, so let's try plugging that one in. Let's try the x equals -3. If x equals -3, I've got 4 times -3 squared plus 6 times -3 minus 10 equals a -3 squared plus -3 plus 2. And then I've got bx plus c multiplied by 0. So the only one that remains is the a. I've got 4 times 9 here, minus 18 minus 10 equals a times 9 minus 3 plus 2. Let's see, I got 36 minus 18 is 18, minus 10 is 8. And for a's, 9 minus 3 is 6, plus 2 is 8. I've got 8a. So a equals 1. Now you kind of have to do the fucking long form. There's no more shortcuts that work here. We need B and C. But we can at least stick in A equals 1. Let's stick in A equals 1. If I stick in A equals 1, we need to multiply that out. You may find it easier to subtract the x squared and the x and the 2 over to the other side at this step. I've got bx squared plus 3b plus c times x plus 3c. You guys with me?
Give me a minute. There we go.
So here we can equate coefficients. The b has to match up with the 3. The 3b plus c has to match up with 5. And the 3c has to match up with -12. I'm gonna literally write all 3, although it should look clear when I do that we don't need all of them. If I match up the x squared coefficients, I got b equals 3. If I match up the x coefficients, I've got 3b plus c equals 5. And if I match up the constants, I have 3c equals -12. So b equals 3 and c equals -4. Three times 3 plus -4 does equal 5. So those plugged into here confirm it. And when you're ready, we put them together to make one equation.
What is the number? Oh, sorry. Such thing, don't take the picture. There you go.
This is what we started with. We found A equals 1. That was over our x plus 3. And then we had bx plus c over x squared plus x plus 2. B was 3 and c is -4. You guys ready for one more bad boy to rule them all?
That's the answer.
Yeah, that's the answer. Let's go big. I'm gonna have x to the 4th plus x cubed plus x squared plus x plus 3 over x times x squared plus 1 squared. So when I break it up into fractions, I have an x. And then an x squared plus 1 shows up squared, so I gotta do 2 of them. The first one is x squared plus 1, and the second one will be x squared plus 1 squared. Anything with an x squared is gonna have a 1 degree lower, and this one has 1 degree lower as well. They're fractions. And have x to the 4th plus x cubed plus x squared plus x plus 3 equals a times x squared plus 1 squared plus bx plus c times x squared plus 1 plus dx plus e times x. We got one shortcut here. Only one thing we can do. We can try x equals 0 to shorthand this a little bit. If I do x equals 0, this is 0 to the 4th plus 0 cubed plus 0 squared plus 0 plus 3 equals a times 0 squared plus 1 squared. And the bx plus c gets multiplied by a 0. And the dx plus e gets multiplied by a 0. And I move that along. And all that's left over here is 3. And all that's left here is a times 1 squared, which is just a. All right, so I'm gonna make a little table down here. A, B, C, D, E. we need to find all these, and we just found A equals 3. This shit sucks, but you gotta multiply it out. I can stick in A. And I'll multiply the x in here first. I have bx squared plus cx times x squared plus 1. And when I multiply the x in here, I've got dx squared plus ex. And that x squared plus 1, this is x squared plus 1 times x squared plus 1. So I have 3 times x to the 4th plus 2x squared plus 1 there. And then the next set when I distribute, I've got bx to the 4th plus bx squared plus cx cubed plus cx. Then we've got dx squared plus ex. So if I distribute that 3, I got 3x to the 4 plus 6x squared plus 3. Give you guys time to write that down. Okay, so now we gotta gather the variables. So I've got x to the 4th plus x cubed plus x squared plus x plus 3 on the left. On the right, my x to the 4th term is that and that. So I have b plus 3 times x to the 4th. And then if I only got 1 cube, right? Plus cx cubed. I have a few things with x squared. Oops. I have a bx squared, a dx squared, and a 6x squared. For my single x's, I have this one right there, the cx and the ex. And finally, I got just a single constant left of 3. Finally, match up coefficients. B plus 3 has to match up with 1. C has to match up with 1. B plus D plus 6 has to match up to 1. C plus E has to match up to 1. And the 3s we don't even need, they're already matched up. So I got one of them right away. C equals 1. If I solve this one for B, I get B equals -2. Which I can put in here. That's going to let me get D here. I've got D plus 4 equals 1. So D equals -3. And I have C, so I can plug C in right there. I've got 1 plus E equals 1, so E equals 0. Tell me that ain't the coolest shit. It's not bad. So we got to put it all together. Because we have that fraction up here. We got to plug in our A, B, C, D, and E. So that's what we're going to do now. I'll rewrite it real quick because it's off the page. And when we stick in our letters, I wrote too many X words right there. Huh. A was 3, so this will be 3 over X plus, I've got -2x plus 1 over x squared plus 1. And E is 0, so this is plus -3x over x squared plus 1 squared. And that's it. That's that problem. You could make this look nicer. By moving the negative here, right there. I don't recommend doing it here, though. Just on this one. Yeah, and the reason why is because there's nothing else added. If I try to move the negative here, I really gotta move the negative out of that one as well. Which you could do. It's gonna make it look like this. But most people are gonna forget to change this sign. And then it's wrong. If you have the minus out front and it just says 2x plus 1 on top, it's wrong. So you're better off, like, if you write it in this form and leave it like that, you're good to go. You got the right answer. This is stuff you can actually work with when you're doing integrals in Calc 2. You can't do the first one, the big fraction, but you can work with the little fractions. That'll be it for today's lecture. On Monday, we are gonna go over 10.1 and 10.2. On Wednesday, I'm gonna go over 10.3. I'll show you the review. I don't know that I'll have time to go through the review, but I will have all the review answer key up. And if we do have time to go through it, I'll go through it then.
I just have a quick question. Since this is 9.4, the last one, like the other class, we got 9.5.
What about it? What was your question?
Like
Just stated a bunch
why
of facts.
like why this number is like this number is like before?
Because did you notice how 9.4 took all fucking day? And
Yeah.
9.5
Oh,
didn't.
so you changed
I-
it so we have time
I
to
changed the
cover it.
order so that
Oh,
I could
okay.
get two topics in one day.
I was asking because maybe I was wrong with the numbers. That's why. That's why
No,
I'm
no,
asking.
the numbers are right. This is 9.4, the other one was 9.1 and 9.5.
Oh, okay.
9.1 and 9.5 were on linear systems of equations and then nonlinear systems of equations. They actually went together better. And then this has the partial fraction decomposition, which to do it justice takes a while.
Next week is gonna be our last class.
Next week is our last week of lecture. The
mhm.
final exam is on Monday,
On Monday of the
the 11th,
11th.
December 11th.
Yeah, I just have a question. That does the like the where you get help? It's gonna be open.
What do you mean?
The place where you get help with math or whatever do you need for homework.
I think the math lab is gonna be open all the way up till then.
Yeah, because that helps a lot. Yeah.
I'm pretty sure they keep it open all the way through finals week.
Okay then.
Okay, I will see you
Thank
guys
you.
on.
Have a good day.
You have a good day too. I'll see you guys on Monday. Have a good weekend. You're almost done. Don't tap out yet. Finish strong. Okay?
I will make you proud.
I hope so, Josue. See you guys.
Thank you.
See you, Johnny. And Roberto.